So let's solve some equations with fractions in them. Same idea. Want to get x by itself? We often do that by undoing an operation. So let's start with the one on the left. If I multiply both sides by 7, look, you don't actually have to multiply this by 7 too and this by 7, because this is just one big happy family right now. This is one term because this and this are connected by multiplication. So this is perfectly balanced what I've done here in red. And I multiply by 7 again, because 7 times 1/7 leaves you with just 1. Completely cancels out the number, right? Because 1 times everything in the parentheses would just be everything in the parentheses. Alright, so a lot of words I just spewed at you there. But basically, if you want to get rid of 1/7, multiply by 7. And then to finish out, this is just a one-step equation now, right? Just subtract 2 from both sides. So I get x is 47. Let me see. There's a few different ways of doing the one on the right here. What would be easiest? I like to get rid of fractions in the first step. Okay, so I'm going to multiply everything in this equation to keep it balanced. I'm going to multiply everything by 6. And the reason why I pulled the number 6 out is because I know 2 can fit into 6 evenly, and I know 6 can fit into 6 evenly. That's going to make my fractions cancel out. Okay, there we go. So 6 times 1/2, you might want to write that off to the side. 1/2 times 6. You could put a little 1 underneath the 6. Then multiply straight across the top, straight across the bottom. So that's going to make 3. It's perfectly cancel out the fraction like we wanted it to. But then we have to also distribute the 6 to this plain old number 6 too to keep the equation balanced. So 6 times 6 makes 36. And then 6 times 1/6. Remember, like we saw in this last one over, that makes 1, right? There. When you multiply a number by its reciprocal, it makes 1. And now we just have a two-step equation to solve. You want to subtract 36 from both sides. So get 3x equals negative 35, and then divide both sides by 3, like we've done before, right? So we get x is negative 35 over 3. Let me see. I wrote down some problems from your homework. Yeah, I got another fraction question for you that I can do. So if we have a over 4 equals a minus 2 over 3, got some fractions going on. To solve this equation, what you probably want to do it by, I don't know, there's two different ways. Actually, before I do this one, sorry, I hope this isn't confusing you too much. Let's do this one first. A ratio question. You're going to see these later, okay? Let's say 3 over x equals 12 over 5. If you have two fractions that are equal to each other, one trick you can do is you can multiply the things that are diagonal from each other. 3 times 5 makes 15. And set that equal to the other thing being multiplied diagonally. X times 12 makes 12x. Just simplify that equation real fast, right? The last step is to divide both sides by 12. I'm going to make another video for reciprocals in case you weren't sure what I did there. And I just need to reduce that fraction, but that would be the answer. So you could do that with this problem, okay? Multiply the diagonals. A times 3, the convention is to write the letter second, okay? You could write A3 or 3A, both are the same thing. And then if we do 4 times A minus 2, you write a 4 and then a parentheses A minus 2 because you got to multiply everything up here by 4. Okay, so if we distribute that, 4 times A makes 4A, and then 4 times minus 2 makes 8. And then to finish solving this equation, we've got to get the A's together, right? Because we've got to have just one A. So let's subtract 4A from both sides. So if you do that, you get negative A equals negative 8. And then divide both sides by negative 1 to finish getting A by itself. So we get A equals 8. Okay. Message me if there's a different fraction problem you want help on.